Have you ever wondered where black holes come from? What could possibly cause such a monstrous cosmic entity to exist? The genesis of a black hole is a tale of cosmic proportions, beginning with a massive star at the end of its life cycle. As the star's core runs out of nuclear fuel, it can no longer support its own weight against gravity. Its demise is not quiet, but rather a spectacular supernova explosion. This stellar death throes leave behind a remnant core. If this core is sufficiently massive, gravity takes over, causing it to collapse inward upon itself. The core implodes, shrinking to a single point of infinite density known as a singularity, surrounded by a boundary from which nothing escapes, not even light, the event horizon. Thus, a black hole is born. So it's the death of a star that gives birth to a black hole, an entity as fascinating as it is terrifying. Now that we know where black holes come from, what do we know about their structure and properties? Black holes, though seemingly simple, are incredibly complex cosmic entities. At the heart of a black hole lies the singularity, a point of infinite density. Here, our current understanding of physics breaks down, and the gravitational pull becomes infinitely large. This is the spot where a massive star once sat before its grand gravitational collapse. Surrounding the singularity is the event horizon, often referred to as the point of no return. It's the boundary that, once crossed, traps anything, even light, within the black hole's unforgiving gravitational pull. Some black holes also feature an accretion disk. This glowing disk of gas and dust is formed from matter drawn into the black hole's gravitational pull from nearby stars or interstellar gas clouds. As this material spirals inwards, it heats up, emitting intense radiation. Black holes are not one size fits all. They come in a range of sizes and types. Stellar mass black holes, for instance, are a few times larger than our Sun. At the other end of the spectrum, we have supermassive black holes with masses millions or even billions of times greater than the Sun. Nestled between these two extremes are the intermediate mass black holes. Despite their ominous reputation, black holes are not just vacuums in space, but entities with distinct features. Black holes, with their intense gravity, seem to hold everything captive. But did you know they might actually be slowly leaking? This idea comes from none other than the brilliant physicist Stephen Hawking. His theoretical prediction, known as Hawking radiation, suggests that black holes can emit radiation due to quantum effects near the event horizon. Let's break that down a bit. According to quantum mechanics, pairs of virtual particles, one particle and one antiparticle, are constantly popping in and out of existence throughout the universe. Now, if this happens right at the edge of a black hole, one particle might fall in while the other escapes. This escaping particle is what we call Hawking radiation. Over a humongous timescale, this process could cause the black hole to lose more mass than it's gaining, leading to a gradual evaporation. So, contrary to what one might think, black holes might not be eternal after all. If black holes are known for not letting anything escape, not even light, how do we know they exist? The answer lies in their profound impact on the surrounding universe. Even though we can't see black holes directly, we can infer their existence through a variety of ingenious methods. One such method involves X-rays. Some black holes are surrounded by an accretion disk, a whirlpool of gas and dust spiraling inward. As this material gets drawn into the black hole's gravitational pull, it heats up and emits intense radiation, including X-rays. By detecting these X-rays, astronomers can infer the presence of a black hole. Another clue comes from the motion of stars. If a star appears to be orbiting an invisible object, that object might be a black hole. By studying the star's orbit, astronomers can estimate the mass of the unseen object, helping to confirm whether it's a black hole. Then there's the phenomenon called gravitational lensing. Black holes have such strong gravity that they can bend light from objects behind them, creating a distorted or magnified image. This lensing effect can provide indirect evidence of a black hole. Through these and other methods, scientists are able to observe the unobservable, bringing black holes out of the realm of theory and into the light of scientific understanding. While we may not be able to see black holes directly, their influence on the universe around them helps us to know they're there.